There are many technical aspects to consider when designing a network, power consumption being one of them. Now there's a huge difference in power consumption depending on the type of equipment that you're choosing. If you want to find out how much, stick around and we'll check it out. For this comparison, let's have a look at metro transport solutions for distances of up to 70 or 80 kilometers. Now this is a nice scenario because we actually have 4 possible technical solutions where we can compare the power consumption. Let me explain. Now to start off, we have the grey link. In other words, we've got the host equipment, and in that host equipment we've plugged a grey transceiver. After that, we've got the passive WDM solution. In other words, we've got color transceivers in the host equipment and a passive optical multiplexer. Then we also have the transponding solution, meaning that we've got grey transceivers here going between the host equipment and the transponder, and on the other side of the transponder we've got color transceivers which are then hooked up to the passive optical multiplexer. And last but not least, we've got the muxponder, meaning we've got grey transceivers between the host equipment and the muxponder. The muxponder then aggregates those signals to a higher data rate, and then here we've also got the transceiver with that higher data rate. Now to be able to compare these different technologies, we first need to set some ground rules. And the first ground rule being that we're only looking at the transport equipment. So in other words, we're not considering the host equipment, so the switches, routers or DSLAMs, but we're starting with the transceivers that are plugged into the host equipment, and also we're looking at the complete link. Now, since data rate also has a huge impact on the power consumption, we're looking at the power consumption per data rate and per link. Of course, another thing that has a huge impact is the temperature, and that's why we're considering 25 degrees Celsius for each piece of the equipment within that link. Now the trickiest part actually is the active solution, because depending on the vendor, the power consumption can vary quite significantly, and also a lot of these solutions are based on a modular system, meaning that if you would consider only a partially equipped chassis, that wouldn't be very preferable for the power consumption. And for that reason, we've actually taken our active solution, so the Cubo system, because we're at the lower end of the power consumption compared to other vendors. And also we've taken a fully equipped chassis and divided that by the number of links from that fully equipped chassis. And last but not least, we have the cooling, because and what we've done there is we've taken the rule of thumb that for each individual watt of power consumption, we've added another watt for the cooling. Now let's have a look at that comparison. Down here at the bottom, that pale blue line is the grey link, and what you can see is the power consumption per link based on data rate. Above that, we've got the orange line, which is the passive optical multiplexing, and as you can see, it is slightly higher in cases, and that is because the power consumption for the color transceivers sometimes is a little bit higher. Now this blue line, this dark blue line, that is the transponding solution, and you can see that is already quite significantly higher, but the active muxponding solution actually by far is the highest power consumption per link based on the data rate. And as you can see, that is quite such a significant increase that in cases it can actually be more than 50 times higher than the passive optical multiplexing. Now, does that mean that you should only be using passive optical multiplexing for your metro transport links? Well, no, because as I mentioned at the beginning, the power consumption is only one of many technical aspects that you're considering when designing a network. But if power consumption is a major topic for you, then it's definitely worth looking into passive optical multiplexing. So, I hope you learned something today and that you enjoyed this video. If so, please leave a comment. Also remember to follow our channel so that you get your regular dose of brain snacks. Until next time, bye-bye.